Hi, and welcome to Mplus Workshop 6, and this is Demo 21. In Demo 21, we're going to be running several confirmatory factor analysis. This is the model that we are going to be running in the CFA. It is a model of 6 indicators, and those 6 indicators refer to academic ability, self-concept, aspire, that is degree aspiration, then the degree actually completed, occupational prestige, and income. And we're trying to develop a measurement model to relate these to a smaller set of factors. Our theory and our prior research with an exploratory factor analysis has indicated that these 3 are determined by a loading of motivation, like a single factor, which we're calling motivation. And SES is a single factor that these variables, degree, prestige, and income, are regressed on. So that is what we are, that's our a priori measurement model. For this example, we have a correlation matrix as our input data. So it is called motivate.txt. And just a reminder, when that is the case, that implies that the variables are multivariate normal and not highly correlated with each other. If there are problems with the measurement level of the variables, you cannot change to categorical or any other non-default features on Mplus when you have a correlation matrix. Okay, so here, let me open this up a bit. All right, so here is Workshop 6, Demo 21 _ CFA. In this, we have here, as I mentioned, the file name is Motivate. It is a correlation matrix. The number of observations that we are assuming is 3,094. And again, this is, I generally take my examples from textbooks or online materials. So this is taken from the Schumacher and Lomuck's textbook, A Beginner's Guide to Structural Equation Models. It's in Chapter 6. So because there are so many observations, one of the examples, one of the fit indices we often use for CFAs is the chi-square statistic. We want to test whether the implied variance covariance matrix fits well with the sample variance covariance matrix. And so the chi-square test tests whether they're significantly different. So if the chi-square test is significant, that means those 2 are significantly different. That's not good. So we want the chi-square test to say that they're not significantly different. Unfortunately, anything in terms of observations over 200, it's going to show that they're significantly different. And so regardless of what we're going to see here, that is not really going to be a good fit statistic. So we're going to look at other ones. And the 2 that I generally look at are the CFI and the RMSEA. So those are the ones we're going to be looking at here. Okay, so here are the names of our variables. Analysis type equals general. So the first approach we're going to be doing is the default, and that is the loading for the first indicator of every factor is constrained to 1. So remember, with a confirmatory factor analysis, we have no metric. So we have to define a metric by which to calculate, allow the model to calculate all the coefficients. So our model is motive by academic, concept, and aspire, and SES by degree, prestige, and income. And I do want motive, the 2 factors, to be correlated. As I mentioned when talking about the exploratory factor analysis, generally we think that our models are such that the factors are correlated in social sciences. So I'm going to ask for a lot of output, including modification indices, and I'm going to ask for a certain plot. All right, so I'm going to run this. Here we go. And actually, the first thing I want to show you is the diagram. So here, let me move this a little bit. Here you go. So you can see then that the first indicator for motivation was academic, and so it has a factor loading of 1. That is not estimated. That is actually constrained to 1. So that is not anything that's calculated in the model. That's the starting point. And then compared to that, the other two loadings are 842 and 457. And then for SES, degree is constrained to 1, and then prestige has a loading of 617 and 265. These are the error variances, or actually they are measurement error. And then in this measurement model, we do have to have some sort of connection between motivation and SES, and that is our correlation. So they are correlated at 0.251. All right. And so next I want to look at the other output. There we go. And so with the CFA, we see all of these we see that we have 2 latent variables that are continuous. If you had any thoughts that they might not be continuous, you would have to put different syntax in your model commands. And so here are the correlations. It's always good to compare those with your input file to make sure that's being read incorrectly. And as we look through here, we see that, of course, our model chi-square is significant. But as I mentioned at the outset, that is not a surprise. We look down here, the CFI and TLI are both good. The CFI being over 0.95 is excellent. The TLI at 0.927 is also good. The RMSEA between 5 and 8% is great. So this is a pretty decent footing model already. Let's look at the model results. Here we see the same coefficients as we had in the diagram that we were looking at. We have each of the factors have variances, and then we have residual variances. Now, one of the exercises in this book asks for us to see if we could find a way to improve the model fit. A typical way is to actually look all the way down here to what are called the modification indices. The modification indices are ways that you can improve your model fit by adding a path. So, for example, if we were, you really want to look at the ones that are the largest. So the largest one would be to actually put aspire as a indicator of SES. But instead of actually, we may not want to completely change the model structure by doing that. We may want to just allow for some added correlation. So here it suggests that we correlate concept with academic. And so that's what we're going to do next. So I'm going to say concept with academic. I already have it written down there. So that means that the error variances for concept and academic are correlated. Let's run that. And I am going to once again look at the diagram, and you can see what has happened. See, these two errors, these error variances are now allowed to correlate. And it does change some of the other factor loading. So this factor loading is actually going up above 1. At some point in time, you might want to just refer to standardized factor loadings. And there is a way that we could view, we could just use the standardized factor loadings. But in that case, this is no longer a 1. So it's a little, I find it a little confusing, since I always like to know which is my indicator variable. All right, then let's go back to the results here. This is all the same. It did improve our model fit for both the RMSEA and the CFI and the TLI, so that's good. And once we go down here, we'll see that their modification indices, and it says that the minimum for printing is 10, and so no modification indices are above the minimum value. So at that point in time, we have improved the model fit a lot, which is terrific. Okay, let's think about one other thing we could do. Oh, I wanted to show you this. So I'm going to take that out and also take out this statement that motivation with SES, just to, so you, yeah, I do want to, so you can see that even, it's one of the places in Mplus that even if you don't state it, it just assumes as a default that your factors are correlated. All right. Okay, so I am going to now put comments in front of all of these. I'm not doing a good job of that. There we go. And then in the next, I'm doing this in the out file. I did not want to do, so I want to do it here. Okay, so here we go. And now I want to take the second approach for setting the metric, and that is the factor variance method. And in the factor variance method, the factor variance is constrained to 1, but in the first indicator, instead of it being constrained to 1, it is freely estimated. So I'm going to actually take out all of those. Okay, so you see that this asterisk is added, and that means please freely estimate that first indicator loading and freely estimate that one as well. And this all by itself, motive at 1, since motive is one of our factors, it's saying constrain the motive factor variance to 1 and constrain the SES factor variance to 1. And need to delete that. So let me see if I should be able to get a new one here. Yep, here we go. Okay, so now you see that the indicator of academic is now has a factor loading that's not 1. So that has been freely estimated. And the same thing with degree. And now I see that the factor variances, which are here, are both constrained to 1. I'm going to show one other thing. I actually remember that we saw that Aspire could actually be loaded on SES. So I'm going to show you how to do that. I'm going to go down to this current model, and I'm going to put Aspire into SES as well. And run that. I did this again. Let me go back here. And so now I'm going to quickly look at the diagram. And you can see that SES and motivation have an arrow to Aspire, meaning that Aspire loads on both. That's called a cross-loading. And you might have a research example where that would be important for you to use. And just to show you here, that is, the model is fitting very well right now. And you can see the Aspire has a loading on each. Both of the loadings are very low though. So you're actually splitting the loading in between the two factors. There are a lot of good resources for learning about how to calculate model fit and examine model fit. One of the things that you might want to do when you're running a CFA, let me look back at the diagram. You might decide this was your original model and you want to actually trim it. So you take one of those factor loadings or paths away. And when you do that, you can compare your chi-square fit with the original model to the trimmed model and determine if that chi-square difference is significant to see which of the two models would be the better fitting model. And so that's all I have for CFA. Still, each one of these is turning out to be rather long. And the next demo for Workshop 6 will be on SEM. Thank you.